Hello, YouTube. Hopefully this is now live. I wanted to do a quick explanation about curve calculators and tides. Now, this came up after a hangout today with on Nathan Oakley's channel, a debate that was going on. Just going to see if I can get a more magnified view of this on screen now. It looks like 200% is the best I can get. So the point, a point came up where we were discussing the what happens on a on the curve calculator if you are taking a shot across sea where the tide is out. How does that affect what you should consider, how you should interpret the values you get from the curve calculator? Now, it came up in discussion with Anthony Riley. And Anthony has a video where he is looking out over the sea at St. Bees and it is low tide. Now, what I've tried to do here is draw a representation. Now, this is a simplification, and all these such diagrams, even the ones on the Metabunk site, are simplifications. We're assuming here that the sea follows perfectly the arc of a curve, a sphere, which is the radius of the Earth, and you know, it's not really like that. Water is likely to sort of bend more, level out more, curve more in places depending upon the tide and the air pressure situation and so on. But as a rough approximation, or as good an approximation as we can get, this is the best way to look at it. Now, if we look first at the blue line, so the blue circle is showing. Let's just bring that. I'll get this one to go to the back. Okay, so the blue circle here is showing the Earth, say, with the tide at what is considered to be average sea level. So sea is at average sea level. And our observation point here looks across and we see this much of the object on the other side, with the amount below the line, the blue line here, is hidden. Now, if the tide is out, and we estimate that we are in fact at this location here, we are a few feet higher, so that we now have the effective height given by the green circle here, the height above sea level. If when we plug the numbers into the curve calculator, we simply add this height here to the height that we're observing, the curve calculator is based upon the curvature of the Earth and a sort of average sea level kind of height. So all it's doing is raising our height above this blue line and then calculating on the basis of that blue line. And so the calculation we get, or is the one shown by the purple line here, which runs across and gives you this height hidden and this amount visible. So it's a greater amount visible than you would have if you hadn't taken into account the tide height of the observer, the observer above the actual sea level. However, what the observer is actually looking at is the red line. They are actually looking at what the red line shows here. And the red line goes across the surface of the actual water at low tide, and it would hit a lower point over here, i.e. more of what is on the opposite side of that observation is visible. So simply adding tide height to the observer height doesn't give you a correction for what the tide actually does. It only gives you partial correction of that. In order to get a full correction, you need to effectively reduce the height of the object that you are looking at by the same amount as you increase the height here. This is a false position. The actual position of the observer is here where the blue and red lines meet. That's the height that the observer is at. What has altered is this point in the middle. The tide being out and the reduction in the level of the water gives your horizon point this height here. It doesn't change the distance to the horizon a great deal, but it does in this diagram at least. Obviously the curve of the Earth is far shallower than this, and this is, as I say, it's a diagrammatic representation to be as accurate as we can. So this red line represents accurately what we see. The blue line represents accurately what you would see at average sea level. And the purple line represents what the Metabunk calculator will tell you if you simply increase your effective observer height, but don't take into account what happens at the other end. So this is an explanation for Anthony Riley, for Nathan Oakley. Nathan seems to completely fail to grasp this and also demand an explanation. I've just noticed, actually, I think the horizon point does move from here to about here. So it is extending the horizon, as you might expect, but not by, on this diagram, not by very much, but it would extend the horizon height. Anyway, I digress. Nathan is demanding a citation for what I was saying. Now, it is a ridiculous thing to say. When somebody explains something to you and points out the geometry that involved, you don't have to accept what they're saying at face value. You can examine it yourself. But to demand that some other person somewhere in the world has published something like the video I have just made does not add any credibility to what I'm saying. It only means that someone else has thought of the same thing. You have to decide whether this is correct, whether this geometric analysis here is correct or not. And if it is correct, then in your opinion, then you accept it. And if you think it's wrong, then you reject it. And if you want an expert opinion, you go and get one. I don't know whether anyone has bothered or even thought about explaining this. And if they have, hopefully they've come to the same conclusion I have. I'm quite happy. If someone can show me that I've got this wrong, I'm quite happy to say, okay, fair enough, I got that wrong. But to me, it seems very obvious. The red line is representing what actually happens at low tide. The blue line is representing what actually happens when the tide is higher and reaches, well, in this case, I've set this to say it's average sea level, but you could say that's high tide and low tide. It makes no difference to the geometry involved. And the purple line represents something false. It represents something that a curvature calculator would give you if you simply try to compensate for the tide by raising the observer height. So that's all I wanted to say on this. Hopefully Nathan and Anthony will get to see this, because they were the two people who seemed to want to challenge what I was saying. And by all means, guys, respond and challenge if you wish to. think I'm still live, so I haven't actually shut this yet. I just want to have a quick look and see if there's anything in the chat, although the chat doesn't seem to be coming up. There we go. I think I'm still live, so oops, better mute that. Okay, okay, Everett. Yeah, yeah, you can't use logic. Of course not. Okay, a few people have watched. I think I'll shut this down because basically I think I've made my point. I just wanted to see if there's anybody around in the chat. Of course you can use logic, for heaven's sake. You know, and not just logic, but maths and geometry and diagrams to see if you can explain what is actually going on. Anyway, hopefully my point has been made, and if I'm wrong, someone will show me, I'm sure. I don't think I am. Okay, cheerio again.